My name is Mehul Rawal. Chaisan, am I audible clearly to you? Okay. So, this is some initiative that we have taken at Ahmedabad University, and I am just new uh, to this particular APAN meeting. So, thank you, Chaisan, for giving us the chance, and of course, to the other colleagues as well, who has helped me to create this particular presentation. So just to share with you about university, we are a pretty young university, maybe about 13 years old now, and we are not-for-profit research university, and we are running about three schools currently looking at School of Management, School of Arts and Sciences, which is our youngest baby, and then I am from School of Engineering and Applied Science, which is about 10 years old school that we had. And we are rapidly expanding. So these are all different phases through which we have gradually introduced different courses around. And this is something about the school. We are located in a state of Gujarat in India, in a city of Ahmedabad. And currently, the School of Engineering and Applied Science offers three undergrad programs in computer science and engineering, chemical and mechanical engineering. And we also have an MTech, which is a Master of Technology program, which is a postgraduate program in data science and analytics. And every year we enroll about 10 to 15 students in our PhD program as well. These are some acknowledgements. The thing that I'm going to share with you as a part of the open sharing data that I'm looking at is coming from my colleague, Dr. Mazad Zaveri, who is working with me in the intelligent transportation system. And he has pioneered some of the efforts in the OSD and specifically some of the points that I'll be talking about is looking at some of the challenges that I'll be discussing through this presentation. I'm also thankful to my colleague, Dr. Ratna Ghoshal. She's from School of Arts and Sciences. And we are trying to link ecology, data science, and machine learning. And as a part of it, there is an open data that is getting generated. And of course, to the PhD scholars, Brinky and Yagnik, for working in and off the field. And then to some of the undergrads as listed out over here. We are currently working on a drone-based data imaginary. I'll explain you the reason why the drone is a preferred modality. And these are some of the specifications of the drone that we are looking into. It is DJI Mavic Pro. Looking at a 4K resolution of videos that we are getting with about 100 Mbps of the bitrate, and it's a very low payload with a camera. Maybe the total payload weight is about 1 kg or 900 grams, as you can see. And we are dependent on a mechanical gimbal to have the pan and tilt in the camera. Now, some of the things that we are interested in looking at is from an intelligent transportation system perspective. And we are interested in looking at a problem of automating the road safety audit. So in India, typically, there are 50 lakh kilometers of highway that has been built. We are one of the fastest country in the world to create that type of infrastructure, and that needs monitoring. Current practices are to do it manually. So a road auditor will go to the site and then check whether all the applicable rules are present or not. We would like to sort of automate that particular task. And we are interested in using computer vision. That is why you can see all these different types of scenarios where the videos are captured in the junction in and around Ahmedabad city, where we are currently looking at. And it goes through several steps like looking at object detection, then tracking the object. This can help us to find different trajectories of the object. We are also interested in looking at ideas of traffic rule violation as and when this particular data is getting created. So currently, we are capturing a data which is about 5 minutes of videos, which are coming at a 4K resolution, and then subsequent junctions. So it's a roundabout like these, which is in the second picture, is what we are interested in capturing, and several junctions are captured. The other thing which we are also looking at is to identify individual mugger crocodiles in the wild. That is how this particular data set is being getting created. This again is captured through drones, as you can see. And there are 4 different districts in our state of Gujarat, which we are visiting geographically, visiting these places to capture these animals, and they are being done through the drone. So this is like about very short videos. These are maybe varying from 1 minute to 2 minutes of a videos, which is being taken through a drone flown at about maybe 10 or 20 meters of a height, and then it is rotated all around to capture these animals. So this is another open data set which we are looking into. Now, what I'm going to narrate, since this is more on an open sharing and data component, I'll be discussing some of the challenges that we are facing, and then how to go ahead in that. Maybe some suggestions can come from the member later on. So I have divided this into 3 phases. The planning part of it, what to do after the capture, and then subsequently how to release out these particular data sets to a public at large for the access, right? So in a planning phase, for each of these, you would need an input from an expert. Sometimes you have your own connects, so you can have a courteous call from an expert and they will do the job 1 or twice for you. But maybe many times we need the professional inputs to look into. The other thing that gets involved, there is a lot of risk involved when you are trying to work with wild animals, because behavior is completely unpredictable. You are not very sure how to go about it. Then you would also need stakeholders for the use cases. So for example, in our case, it could be Ahmedabad Municipal Corporation or a non-governmental organization who would like to look at this particular data, or for that matter, the wildlife data is of an interest to IUCN. So we need that stakeholders, we may have to approach them. One of the things that we are also looking out is we have to seek a lot of approvals specifically. And in our case, we have to deal with forest departments, we have to deal with the police department, because they are giving the local approvals. Sometimes these approvals are also coming for a very limited duration, saying that you may have to capture data maybe within 1 fortnight type of thing. Dealing with multiple authority levels, sometimes for an academic, that's really a challenge, because you are focusing more on academic aspect rather than the other bureaucratic aspect. So you have to deal with authority at local, state, and at a central level. And many times there are these different norms which are applicable, and there are different approval levels that one has to look into. The another task that is of an importance once you are looking at gathering all this data, what is to be done with that? So what we need is a data annotation. I'll talk more on it in the next slide, but it is looking at a very repetitive and a tedious task. That's what we are looking at specifically if you are dealing with big data, and that's about few GBs of data set that you are capturing. Availability of annotation tools, maybe many times they are not available, or I mean, in a sense, more of the paid tools is one that you have to look at. You will need volunteers. Fortunately, we are an educational organization, so maybe we can tap into some of our students, but to really get them hanged on to the job for a long time is a challenge. So we need to look at the paid efforts, and that would need some money to come in. Data annotation, as I was looking at, you need to develop a customizable tools. So there is a lack of customizable tools. That is a challenge. And one of the important thing that we are realizing is there is a lack of unified formats for annotations. Many times, as we are realizing, you need a context-based labels for the annotations that you are carrying out. See, for example, when I'm interested in detecting a small object, maybe I'll need a label per frame. Or maybe if I'm looking at a tracking, then in that case, I'll need a label over a group of frames. And many times I would need a very label for a very specific objects. In, let's say, I'm looking at a very large scale objects or a video, or large scale animal or a video, maybe then in a very specific frame, I'm looking for those labels. So there is a lack of unified format. And on a top of it, if someone like me who is working in a computer vision domain, you need to focus on the input criteria for the model that you are training. So therefore, it may happen that if I have a 4K resolution image, maybe I'll have to convert it to 500 by 500 scale image and then feed it to the input, which is the loss of data that can happen. When we are looking at providing an access, there is a lack of guideline and policy at many different places. Say, for example, what type of a license to be applied for. Let's say, for example, this is about providing an access. So if it's a open source license, which we are looking at, what exact category of the license be applicable to the data set that you have generated when you are releasing it to the public at large. And one of the question is how to prevent the misuse, because it can happen that the transfer of information can really go into an unwarranted hands. And therefore, checking the authenticity of an end user is always a big question for us to look into. We can always place whatever data that we have generated onto the free repositories, but they have limitations. So they may have their limited space, and there are also issues related to the controlled access. So therefore, maybe when we want to release it to the public at large, one can decide on the cloud-based solutions. But cloud-based solutions, there are several issues. More or less, they are expensive. Availability is a challenge. Sometimes due to various reasons, maybe electricity or internet connectivity and so on. And it has also a recurring expense, because what you'll have to do is there is a year-on-year renewal through which you will have to do. The other thing one can look at is physical on-campus storage. Like you can look at a storage area network to build on, which could be one-time cost, but you'll have to plan for it. Like what could be the data expansion that I am looking at? If you are opening it up to the public at large, maybe what you will need is a dedicated internet bandwidth to support it, because there can be heavy churn out of in and out of the data that might be happening. And at the same time, you will also need a dedicated IT support to keep this particular facility up and going. So there are and also essentially realizing from an electronics perspective, there are device specific challenges. So one of the things that we have to also do is not just the data, but maybe we can develop the baseline models also for testing that particular data. There are challenges related to the devices that you are using. Let's say, for example, drone. So the place where I am in currently in Ahmedabad, we have a history of the temperature shooting to maybe about 45 degrees centigrade during the peak of the summer, which is in April, May, and June. And in that case, the battery draining will happen more quickly due to ambient temperatures. Currently, there is a lot of flutter in the windy conditions that we are observing. In that case, also, the drone will not work properly. If there are cell phone towers around, while we are capturing the drone in the urban environment, it needs calibration every time you try to fly it out. And especially if the rotor coils are open to in the several category of the drone, then you cannot fly it in the humid or the rainy season. And one of the typical thing that we are observing is that these small drones, right, they are susceptible to attack by birds. Like there are a lot of these falcon and kites that are in and around our place. And if we have an experience that when we fly a drone, they get typically very interested in the drones. Now with the recent remodeling of the drone and its control in India, typically there is a no permission, no takeoff compliance is to be built specifically for the drones which are more autonomous. And if your drone does not have this particular facility to get registered, there is a portal by the government where you have to get registered, and you will have to chart out the flying plan, get it approved, and then only you can take your flight up. That compliance is a issue to look into. And some of these devices, they have a very heavy insurance. So like we never realized until we went out and let's say we are looking at the cost of our own damage. The insurance premium is about half the cost of the drone itself, which is very expensive for us. And many times there are a lot of these government regulations. They have divided in India the flying zones into red, yellow, and the green zone. And typically you will not allowed to be flown beyond a certain height. which could be due to various different reasons. Security is one of them among that. And if we are not given an appropriate height, in that case, field of view which we are interested in capturing maybe is not wide enough for us to do analysis, right? So these are some issues that we are facing. We are trying to release out whatever is the data set that are have been created, like we started with this particular paper, and then the data set typically related to the mugger crocodile is uploaded on the Dryad. It is available under open source licensing. People can use, and also what we are releasing is the model or the machine learning model that have been created to do that. We are working with an drone data set for intelligent transportation system. Once we have a full annotation available, we plan to release it to the community maybe in a upcoming 3 or 4 months. That's our plan so far. And I think this is all what I have to share. I would be keen to get any questions, or if there are any suggestions on what we are trying to do, I'll be more than happy to respond. And thank you once again all for a very patient hearing.
All right. Thank you very much. Do you have any question for him? Yes? Okay.
Yes, please.
Thank you very much. Excuse me. China is one of the strongest in
Sorry to interrupt, but I cannot hear you out. Chai-san, I would request you to please type it in the chat box so that I can respond. I cannot make out anything, unfortunately. If you can just put a question in chat box, I'll be taking it on.
And he can reply. And how can they communicate? I can.
Sure. Thank you. Thank you, Chai-san.
Her last name Sujiu. She was the open science of the UNESCO.
Yes. Hello, can you hear me well?
Yes, we can hear you. Right.
Okay,
Yes.
great. Thank you. Yeah. So, thank you very much, Dr. Chai, for the introduction. So, I'm Sugira from UNESCO, regional office in Beijing. So, is that okay? I have few slides.
Thank you.
Okay, can you see them? Is the screen okay?
Yes, we can see them.
Yes? Okay, great. Yes, so thank you very much again for this opportunity for us to UNESCO to share what we're doing in the region for the implementation of the UNESCO Open Science recommendations. So I will just briefly give an introduction on the recommendation, very briefly, what has been done as an implementation strategies. Then I will present to you the activities that we have in the region, and then what we plan next. So this recommendation, maybe you have heard it already. Yeah, I can hear something. Is it okay? Hello?
Yes.
Yes. Okay, so I continue, yes? Yeah, okay. Yes, thank you. Yeah, so in November 21, then this UNESCO recommendation open science has been adopted by our member states to make available a definition on open science, and then also a framework for open science itself. And then so this open science here is not just open data, and it's articulated around 4 major pillars. So first one on open scientific knowledge, so which is then the scientific publications, the data, and so on. But then also on open science infrastructure, so referring to specific equipment and instruments and repositories and so on as well, and digital infrastructures. And then a third part on open engagement of societal actors, so to then engage with other stakeholders than just the research community or the scientific community, but citizens and involved in participatory science and so on. And then the last part on open dialogue with other knowledge system to then integrate into open science and recognize complementarities between different knowledge system, such as indigenous knowledge systems. So that's the 4 pillars, and we have 7 areas of action, from promoting common understanding to the policy, environmental development, a third one on investment on open science infrastructure and services, then the investment in raising capacities and human resources. Then a fifth one on fostering a culture on open science and aligning incentive for open science, promotion of innovative approaches for open science as a 6th one, and the 7th one on promoting international and multi-stakeholder cooperation. So we've been working on that, and then so we have identified key challenges then in the implementation itself. So we need to change the conventional scientific culture. We need to raise human institutional capacity. We need to identify and develop an adequate infrastructure, including reliable internet connectivity. We need to align then incentives and revise criteria for evaluating scientific excellencies and scientific careers. And we need to address the intended negative consequences of open science practices. So the strategy for implementing the recommendation itself has been launched last year, and it has several levels. So from a overarching level with the Director General of UNESCO Open Science Steering Committee, a global open science partnership, and then a series of open science working group and intersectoral task team. So actually, I would like to invite you, if not, maybe you're already taking part of those the working groups, but I will kindly invite you to participate to the working group on open science infrastructure. So the yes, and so there has been a series of a meeting already. So there are global meetings. So the third one actually has happened 2 weeks ago. And then so I'm just reporting on the one just before that. So during the second session, which happened last year, there were 5 key factors that were identified to be considered to develop and fund and use open science infrastructure. So first one being the transparency of cost and benefits on resources allocated to infrastructure. Then a second one on interoperability to enhance and reuse the infrastructure. So that's something that we should discuss with this group. Cooperative co-creation of community-based infrastructure. And then the need to make sure to use existing infrastructure rather than risking unnecessary duplication. And that's also where then we really need to mobilize the RAND community into this effort of open science movement. And then the last point, key factor being on the harmonization of the effort for this on open science movement by enabling environment with a community standards. And so the last key messages as well during the session were that there was a range of existing open science infrastructure already, and we need to capitalize and piggyback on that. And it was also very important to consider good governance practices, so that including then investment in human resources, and to be able to create sustainable and resilient infrastructure. We also need to collate then all existing infrastructure, and we should then go for developing a global coalition of existing infrastructure would really be useful. And also the fourth point made was that the existence of infrastructure doesn't mean that they're accessible and functional. And so we need to embrace as well, like diverse community needs and standards, and acknowledge also communities that are already developing their own, having their own infrastructure and standards, and they should come into being invited and into this movement as well, and make sure that what is already existing can be also used. And so also the necessity to define a clear mandate and criteria to make sure that transparency of selection process on the index of knowledge platform is properly happening. And then the index of infrastructure must go beyond just openly available, but also make sure that we go to the other pillars, especially engaging other societal actors, and also opening the dialogue to other knowledge system. And so that's why at the global level, there have been development of a series of supporting tools and also some mapping exercise on a different aspect, like the policies, the strategies, the best practices, and also an analysis is conducted on open science financing mechanism and intensive, and the promotion of open science infrastructure. And that's how then you can find actually now a series of a toolkit on open science, on UNESCO open science recommendation, and then in the implementation. So with guides, with checklists, with fact sheets, and with indexes and so on. So they are accessible. You can take the QR code or go on open science, our open science website. So now in the region, so actually before, I'm just newly appointed to Beijing office, but just before that I was at the regional science bureau in Jakarta. So, but UNESCO has undergone regional transformation, and we don't have a science bureau, regional science bureau anymore, but regional offices in each of the sub-region. So Beijing is mainly covering the East Asia. And so yes, but in our region, so we have all of these activities under open science have been implemented, co-implemented with our network, STEPAN, so Science, Engineering, Technology, Innovation, Policy Asia, and the Pacific Network. And we have an action plan since 2021, and and we have three major thrusts in this action plan. And the first one is about science, engineering, technology, innovation, governance. And in this thrust, we are focusing on open science implementation open science implementation. So that's how we've been working then since then into like a first step was a mapping of some pilot countries within each of the sub-region that we have covered in in Asia and the Pacific. And so we have compiled a paper, so published last year on open science for accelerating the sustainable development goals. This is a prospect in Asia and the Pacific. So this study focused on five countries, so from each of the sub-regions. So Malaysia for Southeast Asia, Republic of Korea for East Asia, Pakistan for South Asia, Samoa for the Pacific, and Uzbekistan for Central Asia. And so so let me just give briefly what were the conclusion, especially in terms of infrastructure. So the study was structured in three parts. So focusing on the policy needs and the policy mapping. Second part on infrastructure, and then a third part on capacity awareness and capacity building on open science. So for the for infrastructure, what was found is that in the 5 countries that we surveyed, there was a lack of dedicated resources for open science implementation, so like the infrastructure itself. And then also that there was a lack of long-term cost, not a mechanism for long-term cost support, cost for support and maintenance of infrastructure. And then, so since 2022, we have been working as well with SOI Asia, so School on Internet Asia, and Group APAN on a joint project on an titled Fostering Enhancing the Sustainable Reference for Open Science Implementation in Asia and the Pacific. So we had conducted a survey, and we thank you very much for having replied to that. So we got 10 NRENs replying for 10 different countries. And so the top 3 issues that were identified is still the lack of open science policy, the lack of awareness on open science, especially at the government and academia level, and the lack of regular funding. Maybe I can go directly to the, yeah. So we also requested then top actions for at the policy level, infrastructure level, and capacity building level. And so policy levels, we need clear policies to spell out the NREN's role in open science, and we need also to have policies securing then regular fundings. And we need a facilitator for open science as well. And in terms of top interventions for infrastructure, so needed a network infrastructure support, needing a backbone network support as well, and needing access to scientific infrastructure and services. In terms of capacity building, so 3 major areas came out. So first, the need for training to policymakers, government officials, and leaders of academia and the research institutions. And then a workshop to sensitize RAN staff themselves. And the third request was to organize exposure visits and the sharing of good practices. So at the moment, we have just delivered last week a workshop in Malaysia, which I will present briefly on this, yes. And so this was the last week we gathered in Kuala Lumpur on a workshop with the aim to enhance and strengthen regional open science implementation mechanism. So it was funded by the Malaysian government, and we delivered it with our SEPAN and with our Category 2 Center in Kuala Lumpur, as well as University Technology Malaysia. And so I would like to present here some slides from the Professor Aini Susana, who is from UTM's University Technology in Malaysia, but also she's the chair of STEPAN. And so before the workshop, so the analysis done was that there's still a lack of comprehensive national policies on open science. And also that open science is currently not linked to national blueprints for education, economy, and industry. And we still have quite a lot of top-down approach within the STI policy development and implementation. And that yes, in each of the member states, the promotion of open science is different with different strategies. Also that there was still limited incentives for companies, industries, as well as other stakeholders to participate to open science itself. So the mobilization of other stakeholders than research and academia is still limited. And we also have limited investment for open science itself in most of the countries that participated. Also there was an aspect on ethics, and so still we need a mechanism to ensure then trust, transparencies, and accountability and reliability then for then participating to open science itself. And there were so far still no guideline and standard for sharing data for some of the countries and so on. So, and also we could see that there were limited best practices of open science in our region, even though we have like a very strong champions. So the workshop has been then discussing on raising then enhancing a common understanding on open science and effectiveness of public and policy and investment. And maybe yes, I can skip a bit on this. So anyhow, the workshop itself will come up with a series of recommendations that we'll be happy to share. But then yes, so at the end of the 3 days of workshop, so the ranking of the challenges were that first there is still a lot to do in terms of governance. Then also the need to secure fundings and investments in open science and to strengthen the technology and infrastructure, so to make clear as well that the goals and the use. So I invite everything. This whole workshop actually is the materials and videos will come very soon. Are all available on our platform that you can access through this QR code, and the recommendation itself will also come up here very soon. So then what we next? We will have a joint workshop, and would like to. I already put APAN's name here, but it's within this joint project that we're having. But we would like to conduct a joint workshop on 31st of May in Jakarta, and invited as well to participate online. And the theme will be on open science infrastructure and in AI ethics. So yes, so then within our project, so we had 4 activities. So the first one, we conducted the survey last year, and we are now organizing the series of regional workshops. And so first on, so this workshop in Kuala Lumpur was discussing then, so what about the policies for infrastructure for open science, but not just for infrastructure, but also for infrastructure. So what were we would like also then to have a workshop to share the good practices, and we need, especially in our region, to discuss about what platform we should have for open science. So what would be the Asia Pacific open science platform? So we already have a lot of platforms, but then how would we then define then our regional open platform. And then what will be then the indicators that we should monitor in the implementation of open science within our region, so globally as well, but also any specificity of our region. And so we take all this to then a multi-stakeholder dialogue to share then all the outputs of the different workshops. And so yeah, activity 4 might be within activity 2 as well, with the series of training and capacity building online. And then a second part that we are now starting to work with as well is then the role of engineers within open science, and then so defining and implementing open engineering in open science in our region. What would it be? And so we would be really happy to work with you as well, with this group as well on that. So thank you very much again. Yeah, thank you very much. If you have any questions, please kindly let me know. Thank you.
Thank you. I don't know. You hear me, right? Can you hear me? Good. Any question from the floor? The APAN and join with the UNESCO. Any idea? It's already put the APAN in there already, so we have to discuss how we can join. Any? Okay, if not more question yet, we proceed to the discussion, which is the next session. I mean, sorry, next speaker or next talk is Marcus to lead it. Look at the agenda.
Just made it up.
No, really, it's already there.
So I think Charles just dropping me in this. So, I already said. I think, following your question about how APAN can work with groups like UNESCO and various projects, were you about to ask a question? What we've talked about around this working group is that we have a strategic level conversation that is about research data for all disciplines provided by multiple infrastructure providers. And then we have all of our verticals, our various working groups in various user community areas. So I think there's sort of two perspectives we could take here to help Dr. I and other groups. I know that, I've talked to previous APAN meetings about the Australian experience and the development of what is now the Australian Research Data Commons. And one of the things we're talking about in this working group is how we replicate that, both within individual economies and also across the whole Asia Pacific. And one of the challenges we have is, how do you get started? So we've had many good conversations in the past about particular working groups, and I'll ask, Ninomiya-san and Eric in a moment to talk about how it works in their community. We also want to understand what's happening in each of the economies, because when Dr. Rob mentioned the policy frameworks in Australia, we now have rules around funding that if your research project collects data, you must make it shareable or explain why not. Okay, so by default, every researcher in Australia now has to spend some time thinking about how to do this and how to do it within the budget constraints of their research grant and all that. And that's why we have these other programs that provide training and support to researchers how to manage your data. They provide repository facilities that are run by institutions long term, maybe with a particular discipline focus. So I'm on my shoulder, and every time you move, I keep thinking you're going to ask me a question. No? Okay, that's all right. So I think it's useful to, and this is something we've talked, Junichi-san has talked about with the building the data.apan.net site is to make all of these things visible, to at least show that there are nations, economies that have started to develop good policies, good frameworks, and very importantly, driven that culture change. Let me pass it off first to Eric, if you're okay, to just talk about in your discipline community how this works and changes. Oh, sorry, I'm not sure what Chai's doing.
Thank you. It's the most difficult thing to share, at least in our experiences. From back to about 20 years ago, when we started the digital archive program in Taiwan. That's the first step to understand what data you have and to make data accessible through making use of the modern digital mechanisms. That's the first step. And then the second step is that the funding agency forces all the government-funded projects to own the data after the project is finished. That's the second thing. And then most of the data, a research project could be have a repository as a home for those data in the long run. That's the second thing. But most of the users are still, the first thing, not knowing which data is accessible or how to access it. So there should be a kind of a catalog of those digital data sets. And also then there should be a systematic structure or mechanism for the accessibility or reproducibility of those data sets. There's a lot of follow-up issues of this kind. And then after the 20 years, then there is a research data management mechanism, system, services, or repository has been provided. But that's still in quite limited areas. So we are still in the first stage, the beginning stage to encourage the open data and data sharing, at least from the academics in Taipei, Taiwan. Luckily, now there are many investment from international collaboration from the European Open Science Cloud, the UNESCO, and from other countries has been focusing on these topics. And so we can leverage in those mechanisms and work together toward this goal, the common goals.
Thank you, Eric. Wearing my hat as a former astronomer, astronomy is a global community that understood this 50 years ago. And they had an approach to sharing data that was formed back then, before we even had the internet, before we had large databases. And one of the very useful statistics we have is the space-based observatories now. The data is not, the data that comes from the telescopes is not the property of the researcher or the institution. It is licensed to the researcher. You have 18 months to publish your papers, and then the data is made public by the facility. And at the moment, if you think of like the Hubble Space Telescope, for every data set collected that generated a paper for the researcher who collected it, there have been another 6 papers published by other people on the same data. So that reuse, because of that, and that serendipitous discovery is very well established. There are other disciplines as well, biosciences. Can I ask you to talk? Agriculture?
Well, as you know, genetics, they share almost all the data after analyzing procedures available, then after writing paper, they are obliged to, publish the data to the public. And we should have the same mechanisms. And in my research field, we are collecting few images from the crop field and things, and we are buying an AI things, all the things to, get that kind of crop trait information. Then our team has been publishing all the images we can share. And usually in our field, we are kind of obliged to put the link for the images when we publish a paper so that people can utilize. I don't know how many people have used our data. So in some part of the field, the situation has been very improved and the people understand. I think this kind of step-by-step things. In other field, I don't know. But in our field, the situation is quite okay now. Yeah, of course, and also, many things to talk about this, but for example, our government, I have quite a tight relationship with the agricultural, fishery, forestry in Japan. They used to call all the data, but now they own every statistical data set, the public. Of course, usually they publish data in Excel file or something else, so it's not really, but much better than PDF was the paper-based data. Things have been changing. Well, we started this kind of discussion about 25 years ago. Yeah. He said that the disaster mitigation would start 10 years ago. In case of that group, that this year, the 25th, 25 years ago, it started. So from the beginning, we discussed about how we want to share the data. And quite pessimistic that time, but it's gradually getting better, I think. So now I'm quite optimistic. But still, I need to summarize that something else. It's kind of endless talk, so maybe later.
That's actually an interesting point, or a couple of points there that popped to mind when you said about you make the data available and you share a link. And as we all know, web pages come and go. So what we need are things that they persist. So we get into a whole conversation around persistent identifiers and repositories. Because what you want when you publish something, it's the article forever, for centuries. So if you put a URL in there, it has to be valid for when the person's reading it 10, 20 years track. And so there are a lot of repository platforms now that give you a standard framework that also gives you an identifier. So digital object identifiers, handles, the ability to identify our searches with things like ORCID, all those things now exist. And what that also gives you is a value argument for a researcher to do this. Suddenly, it's not just their paper being cited, but they can also cite the data. So if you share lots of data and write one paper, that's great. People can reference your paper. But if 1,000 people use your data and cite your data, that goes to the credit of the researcher who collected it. And that was something that we found really, really powerful in Australia and other places. The other thing I want to ask is, are people aware of things like the International Research Data Alliance? Those of us who spend a lot of time working with data, we know about this. Does anybody else in the room know about them? This is, I would imagine you would. I know Vinicius knows a few. So this is a community that was formed by the governments in Europe, in Australia, North America, where the funding bodies got together and said, we need to do better with our research data. And they align their policies and their frameworks and the development of platforms and toolkits. And there is now an international community with probably close to 2,000 people in it, in 20, 30 working groups at least, in different thematic areas around the sharing of research data. The number of people from Asia that participate in this is a very, very, very small number. And we need to get more. And it's free to join. They have meetings all around the world. Dr. I probably goes to some of those meetings as well, talks about the open science platforms there. So there is a lot of work already being done that we should be also participating in. We don't want to reinvent a wheel. We don't want to develop new standards, because every researcher in the room collaborates internationally. And if you use something different to your collaborators, that doesn't work very well. I'm hoping to get some enthusiastic hands who want to make comments. Somebody else wants to say something. There's also keeping things up. So I need to comment. Yeah.
Now, this one of the what they call them, major initiative. Participating. Malaysia is also participating in like China have and stuff. Being two big initiatives in now working in the world. So I we need to so we is open for the academics. It is very high to that. Thank you.
Good point. So I tend to view RDA as a sort of effort coming upwards instead of funded by government, whereas COGR is sort of the top-down structure. I think it's governments to set up. They will recover it, obviously, like the people. But it's interesting. You use a phrase that I hear a lot is Malaysia participants. It's not Malaysia. It's people, individuals in Malaysia. And some of the people are in really strong positions. And some of them are really, really enthusiastic. And then you have examples of other places where it's not doing anything. I'm not. Wasn't fun. And it's like, sure, so there is benefit of having that sort of international framework. I think the one of the things that research does is it does have a government panel or a finance panel. So it is also a high level of community of people that have your money. They give to us researchers. No, that's a good point. How to align how we participate. It's probably more Asian participation.
This open science framework is following very closely,
Only very closely initiative, but especially on the data accumulation. So the initiative of some 200 people already being alternative to have data in Malaysia. And they are coming to India. The scope is not taking care of the so on the field research refers to the data function
I think that's a really good point. Is that what we lack in this room are librarians. Because at times we tend to do librarians as books and journals, but those journals all come electronic. And the data sets and the ability to find things and share information and standardize on. Librarians are great at this, even better are archivists,
Yes.
because they are ridiculously oriented people about this and done this way. And what we found in Australia was that the research data management, so it's part of the collection of data, all of data. Once it's properly structured and described, then you get into an art shop. It is the curating of the data, and stewardship of the data, and it's the next level on that path. And that's where librarians become really useful. So if you come to Australia, you have the years of labor conference every year, there's 600-700 people turn back. The research data management meetings, probably 30-40% librarians. Because they understand this stuff, they understood that their role has changed. And their expertise is really valued.
We have a
but I can get the input from the expert. So the one that I think will be curated on the scientists. So it's a much more fast to actually walk maybe.
But I think the balance is a little bit easier than we think, because what we're talking about in curation is like the preservation and the application standards and so on. And that's something that researchers don't know how to do.
yeah.
They know they have to use a standard, they don't know how to pick one. Right? And in some disciplines, I mean, some of the licenses, they didn't set their standards for a long time. The geosciences, I was in the room with basically the Australian states agreed a common standard for coordinate systems. Because when they, they were all doing their surveys of data, geophysical data, drilling holes and those sorts of things, they all used different coordinate systems in each state. So they could never do a national map of Australia. And when they did, they found the two states had actually been shifted 200 metres apart, which made it another from crap. But for some reason, all the boundaries shifted to the middle. And so, yeah, they got together, told we need to fix this. And they said, oh, we don't know how. And in fact, most of the geoscience library people who said, oh, just need these kind of standards, you have this kind of approach, and so on. But they don't manage the access to the data, the discovery, things like that, because that is subject matter specific.
Yep.
Right. Yeah. Well, we've got the one of the registry platforms we talk about mesh, which is done in Australia, is out there. So you can draw a square on that and says, what are the data sets that are relevant to this area? Physical, biological, environmental, botanical, whatever. So they're good. But it's a very generic search. Whereas if you're a genetics researcher or a hydrologist, you're going to ask very specific questions. And those might be approached more generally. So there's sort of a certain common, this is the way I think of it. So it's kind of standardized at the bottom, where researchers don't have to know how it works, but then allow them to do it. It's like the network layer. You don't care about how easy what part works, when you care about the web page open your laptop, right? So trust is specialist in some areas.
They want to realize research data alliances, right? So I think we have continue with that and we working with that, I guess. That should be the, yeah. And then the better, yeah. But that is, I this is having good memory, something like that.
So one of the things we're trying to do with this working group, so shared working group. We've got a problem there, but just to summarize off it, is this working group is meant to basically be as many people as possible crowdsourcing all this knowledge and information. So that we can use that, we can take it back to our partners, that's huge governments. And, you know, China is very good, but it's very easy. So I'm not so good, but I'm also very easy. So we need everybody to help out this as well. Yeah, so there's us here. We can put the environment together. Never work with now, the important thing is to get to collaborate.
Right, okay. Let's have a little session and then we have at 3:30. Yeah, 3:30. Level 50. What? Thank you. Well, please stay online. I like the session in like 30 minutes. Please, people can come. The coffee. 20 minutes. Actually,
It's quite difficult to hear.